be important in section 8.5b, but a lot of us, let's just be honest, how many of us are like, I don't remember factoring so good? Oh, come on, way more than that. You don't remember factoring so good. If you did not factor 1 and 2 and 4, if they're not on your paper with parentheses, you don't know it so good. We have a lot of posers right now. Thank you, those of you that were honest and raised your hands. I appreciate that.
Extra credit.
Maybe I should, but for right now, everyone just put their hands down. Okay, so then I said, okay, look for a GCF. And then I asked if you knew what to do with it, and I heard some no's. So pause. Just looking for a GCF. Wait, not number 3, he's already factored. Does 1 or 2 or 4 have a GCF?
Yes.
1 does. Max sees number 1. Does anybody see any other ones with a GCF?
No.
Yeah, I agree. Okay, remind yourselves, number 1, in the process of factoring, the first thing you should try to figure out, we're really trying to label things this semester. Because the more we label it, hopefully the more it makes sense. Let's go ahead and label only number 1 as a GCF. And my question to you next is, what is that GCF? Isaiah, that's not your seat. Move up. 2 and x. You guys all agree with Andrew? And I heard a few others saying it. 2 and x. Is that the GCF?
Yeah.
Good. Okay, so I don't really have to worry that you guys don't know how to see GCF, I don't think. Right, Swanson? Because I think everyone, most of you at least see there is Jeremy. Remember, 100%. We're just following along. So number 1, there is a GCF, and the GCF is 2x, right? But when I asked you what to do with it, that's where we start getting a little bit sticky, right? So what to do with it? Do you guys remember that in factored form, what we're trying to do is make a function look like number 3. How is number 3 different than number 2 and 4? Andrew, help Max out. He's struggling today. Give him a quick help. How is number 3 different than 2 and 4? His eyes were closed, but he heard me talking. I thought you were out. So what do you see, Jeremy? What's in number 3 that's not in 2 or 4? Yeah. Number 3 has parentheses, whereas 2 and 4 don't. Okay, and if you look back on the board, do you guys remember the intercept form from yesterday? Intercept form. It's the one with, I can write it on the front board. It has the A times the x minus p and the x minus q. It's this guy. And remember, if you guys have your, 8.5a worksheet, we were able to take these and we were able to go to a graph, remember? And we were able to graph our x-intercepts from that form. So we like factored form. We just didn't, yesterday, I didn't try to scare you. Yesterday, I don't think, mention the word factor at all. I didn't say it once. I called these guys x-intercepts, and that was what was on yesterday's worksheet. But technically, even though this is intercept form, this is also what we call factored form. So last semester, when you guys were factoring and trying to get your parentheses and trying to get things to look like number 3, you were getting it in factored form. That's an algebra way of saying it, but it's also called intercept form. That's a graph way of saying it. Because then we can go on our graph and we can do something like show P and do something like show Q and go to P plus Q over 2 and plug it in and find our vertex and make a graph. That's like an application of all that factoring that we did last semester, but now we have to remember the factoring. So we're trying to factor, and if we're trying to factor, number 1 is actually easier than the other 3 because he only has 2 terms. Ooh, what are those guys called with only 2 terms?
Binomials.
Binomials, awesome. So binomials, hey, that seat's working. Binomials, I just need to pull out for f of x. If I see a GCF, I just need to, well, the very non-technical way of saying it is pulling out. The technical way of saying it is factoring out. So if there's a GCF, I need to factor, and I'm going to put in parentheses, divide it out. Some of you need to write yourself that reminder, because frankly, you just don't remember from last semester, and that's okay. That's totally okay. That's why we're talking about it today. So if there's a GCF, when I ask you what to do with it, you need to remember I need to divide it out, or factor it out, or pull it out. So what am I pulling out? the GCF. The question is, what's left on the inside? Now, do you see why I'm putting a minus? Why am I putting a minus in there? Yeah, because there's a minus in here. So even though I'm taking out, dividing, or factoring out the GCF, I'm still going to have a binomial here. The question is, what's left? Dividing it out. When I pull out the 2x, remember, I am taking it away from the first term, and I'm taking it away from the second term. This is technically the math way of showing it. Now, I know you guys have graphs on your paper. I left you some white space. We'll get to the graphs in a little bit. Right now, we're just trying to review factoring. So, can you see a GCF? Most of you, the answer was yes. Do you know what to do with it? Most of you, the answer was no. But now we're remembering that you're supposed to divide it out. So out means put it in front, and then divide it. Some of you would do this in your head, and then some of you would actually need to write it. The question is, what is left when you simplify? If I divide 2x squared, or 2xx, by 2x, what's left? Not the 2. Doesn't the 2 reduce, right? See it? The 2 reduces. 2 over 2 is 1. 5 over 5 is 1. 10 over 10 is 1. 2 over 2 reduces just to be 1, but what's left? Not this 2. That's a squared, and x is left. Some of you are forgetting that 2x squared is 2 times x times x. Isn't that what that means? 2x squared is 2 times x.
Yes.
So the 2's reduce, right? But the x's reduce also. So for just a few of you, it would have made things a little bit easier if instead of writing 2x squared, you wrote, oh, what is x squared? Oh, that's right, it's x times x. So what goes away? Well, the 2's reduce, the x's reduce, and what is left? Do you see it better that way? No, because the squared is just showing us there are 2 x's being multiplied. So I can rewrite the squared as an x times an x, and then I can see the 2 reduces, the x's reduce. Old-fashioned, we would have done exponent rules. With division, you subtract the exponent, so 2 minus 1 is 1. That's another way of doing it. But that's just the first piece. I still need what's on the other side of the subtraction. What's on the other side of the subtraction is a 16x over 2x. What's left in that piece, guys? An 8. Not an x, though. Just an 8. Why? X over x, yeah, reduces. Right. If it was a square, there would be an x. Good, Jerry. But the x and x just goes away. And the 2 and the 16 just becomes a 1 and an 8, right? Okay. Now, check it. Do I have number 1 in factoring form? Why? I have parentheses, and I've pulled out GCFs. And if there are any trinomials, I've broken it down more. But do I have a trinomial or binomial? So I'm done. I'm done. Because I was showing you guys, or actually I was asking some of you, I was like, okay, can you just try to FOIL out number 3? And foiling out, some of you guys love the table, and so the table you would have done x plus 1, you would have done x minus 3. If you had FOILed this guy out, you would have gotten x squared minus 3x plus 1x minus 3. You would have gotten, for this guy, x squared minus 3x plus 1x minus 3. Remember, the only time we have to do a table to factor is when it's a trinomial. Only when it's a trinomial. I'll try and help you back. Hang in there. I know it's fun. All right, look in the back of the roll. Okay. Hang in there. If it's a trinomial, we use the box. If it's a trinomial, we use the x method. But guys, we were done as soon as we took out the GCF. There's no trinomial. We're done, done, done. Now, we're going to try and attach this to graphing in just a second if we have time. We're going to try to attach it to yesterday and how we would take something that's factored and graph it. To be honest, this one's actually a little bit trickier than any of the ones we saw yesterday, even though its factoring was easier. Okay, so hold on, pause. What do you do when you see a GCF? Divide it out. Does that make sense?
Yeah.
So now you guys know the answer. If you're trying to factor and you're looking for a GCF, if you find one, identify it, divide it out. And then you're factored. It's done. It's done. Here's the problem. Did you see any GCFs in these two?
No.
Okay. So if it's not a GCF, we have to go to step number 2, right? Yeah, the X method. Now, to be honest, maybe some of you noticed that there's only an understood 1 in front. Maybe some of you noticed there's only an understood 1 in front. I'm curious, and I know it's crazy, and I know it might be way too much of a jump, and so for some of you, I might totally lose you for like 30 seconds. But then I'll come back and I'll review and I'll remind you how to do the X method. But for just a few of you, your brain might click, a light bulb might turn on, and you might realize some of these factoring ones are a lot easier than I thought. Now, if there are like 1 or 2 or 3 of you that this works, it'll help you, and then I'll go back and review it for everyone else, how to do it the longer way. But can I just show you real quick what the answer is to 2 and 4?
Yeah.
And see if your brain can kind of make sense of it. You ready? Okay. Actually, before I do that, if I were to ask you to double check that you were right on number 2, number 1. If I was to ask you to check, number 1, just check. How can you check and make sure that your factoring is right?
Multiply.
Exactly. Every factoring problem can be checked by multiplying. So, check it. Isn't this like a good old-fashioned distribution problem? What's 2 times x times x? Got him. And then what's 2x times 8? Well, across a minus. What's 2x times 8?
16.
Were you right? Were we right?
Yeah.
Totally. Okay, so you can always check by multiplying. That's just a quick reminder. Okay, here we go. For number 2, ready? The factors are x plus 7 times x plus 1. Or it could have been x plus 1 times x plus 7. These factors, some of you remember from last semester, can be written in either order. And you and Everest, you've been doing really good. Hold it together. I know fire drill threw us off. Now, can you guys check number 2 with me and make sure I was right? Because I did absolutely no work. I just wrote an answer down. Is that crazy? Did I have it memorized? Did I do that whole crazy X table chart thing in my head? What'd she do? Well, let's just check and make sure I'm right. So, how would we double check x plus 7 times x plus 1, guys?
Multiply.
Multiply. What do you want to use? You have to tell me, because I just want to do whatever makes sense in your brain. Do you want to do the table, or do you want to do the FOIL? FOIL. So if we FOIL, we would do first, what's x times x?
X squared.
Mm-hmm. Then we would do outer. What's 1 times x?
Mm-hmm.
So it's a positive, so we do positive 1x. What's inner? 7 times x. Mm-hmm. And what's last? 7 times 1. Oops, I already did a plus. Plus 7.
8.
Then wouldn't we combine like terms? So was I right? How did I do it so fast? Did I know what it was supposed to look like with parentheses? Yes, I knew it was supposed to have parentheses. How was I supposed to know, or how could I know that I needed only pluses? How did I know only pluses? There are no negatives anywhere, right? Which means I needed everything to be a plus here to make everything a plus there. Does that make sense? So I could know everything. Okay, so far, guys, even without knowing or having any clue, you guys have just shown that you know how to write it like you knew half of the answer before even thinking about the numbers. Wait a minute, why do I know it has to be x and x? It's an x squared. I knew it had to be an x and x. If there's a number in front, like a 2 or a 6 or a 12, it gets a little harder. But if it's just an x squared, I know what the answer needs to look like. And the pluses, there were only pluses. Now, how did I know it was 7 and 1? This is where we should probably review the x method for some of you. How did we know 7 and 1? Do you guys remember how we're trying to multiply 7 times 1? We're trying to multiply to be the last number. And what are we trying to do to get the middle number? Where did that come from? Addition. So remember, we're trying to think of what factors of a times c, 1 times 7, add to be 8. Well, what multiplies to be 7 and adds to be 8? 1 and 7. So some of you would have done this in an X method first and then gone to the answer. Some of you would have maybe tried to go straight to the answer, but you have to be really careful. If there was like a minus and we had to figure out where a minus went, checking is the way to make sure that you got it right. So just a couple of you might be like, wait a minute, I might not have to do that big old table X thing. Like maybe I can sometimes just see the answer. But you have to remember how factoring works. We multiply to be that last, and then we add to be the middle, and we look for factors that work. Now, technically, if you want to remember the entire process, which even works for the really, really hard ones, we would go ahead and, okay, come on, wakey, wakey. Nope, now he's mad, now he's happy, now he's mad. Tell me about it. He's still out in the field with the fire drill, I guess. There we go. Oh my goodness, he just drew like all my lines at once. Remember how we do the table is that we take the first term, which is x squared, always goes here. We take the last term, which is 7. The last term always goes there. And then remember, we use these two to be our 1x and our 7x. And then we say, what's in common? Oh, this way though. X. But you're right. Jonathan, was that you? What's in common this way? What's in common this way? What's in common this way? Nothing. Oh, good. It's a 1. Hey, guys, was it x plus 1 and x plus 7? Nice. Do you have to do my, like, jump straight to the answer? No, definitely not. There's an X in a box that lets us get the answer. But some of you were doing what we call grouping, and some of you were, or maybe are, thinking, hey, I think maybe I could do what she did and factor without showing as much work. But if you're going to do that, if you're going to try to make this jump, you have to check and make sure you're right. Because it's so easy to mess these up. And you guys know that from last semester. Now I'm curious, without doing an X method, does anybody think they could follow what I did to fill in the factors for number 4? Let me give you a couple seconds to think about it. Now, once again, you don't have to be able to do this in your head. That is not what I'm trying to tell you. I'm just saying, for some of you, it's more possible than you thought last semester to do these faster. It's actually called guess and check. You plug things in and you check and see if you did it right. Kind of think about the 21 is factors. Think about the 10. Oh, it needs to be a negative. Does anybody have something that they think goes inside the parentheses? Doesn't have to be the whole thing, just something. Andrew. Ooh. So we're thinking an x minus and an x plus. Oh, why does, I'm just doing the x's first. Why can it not be a negative and a positive? Yeah. Trey's actually kind of thinking about checking. He's thinking about multiplying. If it was a minus and a plus, what's a negative times a positive, guys? That'd be a negative number. Oh. He's a positive number, though, which means minus. Now, Andrew is saying 5 up here. The problem is, Andrew, you're looking at the 10 when you should be looking at the 21. Remember, we're trying to think of factors of the last that add to be the middle. 7 and 3. See it? You have to know who to look at. Because 10 can be like, I don't know, 1 and 9, and 11 and 1, and 3 and 7, and all sorts of 5 and 5. It could have been a lot of stuff. But 21 is either 1 and 21 or 3 and 7. Why did you guys like 3 and 7? Yeah. Now, how do we check? Multiply. Wait, you didn't do an X method. Wait, you didn't do the table. Wait, you might be right without any of that work. So check it. Ready? The more you get used to factoring, the faster sometimes it goes. What would x minus 3 times x minus 7 get us? What's first? negative 7 times x? What's inner? What's negative 3 times x? And what's last? Did all of our signs turn out the way we needed them? We have a plus 21. We have a negative 7 plus a negative 3, or minus 3 is negative 10. And then we can go ahead and simplify. Now, for those of you with the x method, I'll show how you could have done it. You don't have to make that jump in your head. You would have put the 21, technically a times c, 1 times 21, up and top. The negative 10 would have been down and bottom. Hopefully you would have realized that 7 and 3, both with negatives, multiply to the top and add to the bottom. Then you could have thrown this into your table and said, okay, so x squared goes first, 21 goes last, negative 3x and, negative 7x. Remember these guys go in the other two. What's in common is an x. What's in common is a negative 3. What's in common is an x, and what's in common is a
2, 3.
Oh, here. Negative 7. Oh, awkward. We run the field, we run the field, we run the field. X minus 3 times x minus 7. Were we right?
Yes.
Yes. Now, why did I have you do all? Now, some of you are like, I need to remember factoring. I get it. I get it. Come after school, just not today. I'm not here. But why are we doing factoring? Well, because, guys, we're still in section 8.5. Here's your number 1. You didn't just have this. You had a graph you were supposed to make. So check it. If you have the factored form, which we already did, and if you have the factored form, which we already did, why does it make me still 3 minutes? I don't want to have to keep you guys after the bell, but if you waste my time, I'll have to waste yours. Come on. Why are we factoring? Because this form's not good for graphing. I would much rather have this form. Guys in the back, you're wasting all of our time. For graphing, I don't want it to look like this. For graphing, I don't want it to look like last semester. For graphing, I want it to be factored, because if we could just get it factored, remember, things get easier. We have stuff like automatic points that we get to put in. We have stuff like that nifty formula that we looked at yesterday. We saw that if you get that nifty formula, you can actually get the vertex just by plugging in that x value. You can do all kinds of stuff if you have it in this form. So check it. Over here, when I get it factored, I can come down and be like, oh, so I know that 7, backwards what you see. Negative 7, 0 is a point, and backwards what you see. Negative 1, 0 is a point, just like we did yesterday. 10, 9, 8, 7. We can add those two numbers together, backwards what you think, and we would get x equals negative 8 over 2, which is negative 4. And you would know that at negative 4 is the axis of symmetry. You could put that negative 4 into your vertex, and we would have to go off to the side and say, okay, what is f of negative 4 to figure out our y value? But wait, does this part feel way different than yesterday? No, it's the same. It's the same as soon as we get it factored. So here's the struggle. We just have to make that factoring jump, and then it's the exact same thing we were doing earlier in 8.5. The only weird thing is, guys, who would my P be for this guy? There's no minus or plus with that x. Q is 8, right? But who's P? If you have a GCF, you can think, remember, if nothing's there, sometimes it's a 1 if you're dividing, but if you're adding, it's a 0. So you might want to write that, because if you pull out a GCF, your P would be a 0. Guys, this homework we're going to have due on Thursday. I'll change right away because of the fire drill, because we need to, I think, do like 2 or 3 more examples. But pause before you leave. Long story short, Don't you have to remember factoring? Okay, review factoring tonight. Either way. Bye, guys.